Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the final part of algebraic fractions where we're going to be using them when solving equations. So as you can see here, we're going to again start with some slightly easier questions and work up to the harder ones. But as you can see, we've got an algebraic fraction here as part of an equation. We've now got an equals symbol compared to the previous two videos where we didn't have that. So we've got solve 11 minus x over minus 4 equals 3x. In this case, obviously, we've got x's in two places. We're solving, the whole point is to get x equals somehow x on its own. So I want to get rid of this fraction in the first place. What I mean by that is cancel out the fraction like format. So in this case, I'm just going to multiply by minus 4. Obviously, we have to do it on both sides because it's an equation. So I get just 11 minus x on the left because I've cancelled out the minus 4 there. And then on the right hand side, 3x times minus 4 is minus 12x. So we no longer have any fractions in this case. Now I just need to solve it. I still have x on both sides, so obviously I want to bring those together. There's multiple ways to do this, but I'm just going to add the smaller x there so I don't have to move too much around. So I'm just going to add x to both sides to move that one across. So I've got 11 equals minus 11x. And then the last thing to get just x on its own, I need to divide not just by 11, but by minus 11. Because I do need the x side to be positive. So obviously there I get positive x, and this side we get 11 divided by minus 11 is obviously minus 1. So there we are, we've solved that equation. So that was an easier one where we just had an algebraic fraction on one side, just multiply by the denominator to cancel it out and carry on from there. Let's look at some harder ones. Okay, as you can see, this one is harder. We now have 3 algebraic fractions. However, what we do have is, you see how all the denominators are just numbers, they're not x or anything. So we've got solve 2x plus 1 over 6 plus x plus 5 over 2 equals x plus 4 over 3. There's a few ways to do this, again, different orders that you can do things in. If you wanted, you could just add these two together first to get a single fraction. But what I'm thinking is I just want to cancel out all the denominators straight away. In this particular case, it might not always be the case, but in this case, can you see how 6, 2 and 3 is the denominators? 2 and 3 are factors of 6, aren't they? So I'm actually going to choose to multiply by the biggest number. Times everything by 6. Now just be careful here. I know I've written it down twice, but I do need to times all 3 parts, all 3 terms I guess you could call it, by 6. So the first fraction will just open up and become 2x plus 1 because I'm cancelling out the 6. The second fraction, I still need to multiply by 6 though, because it wasn't divided by 6, I need to still multiply by 6. So I'm going to put 6 in the numerator. When you're multiplying by a whole number, when you're multiplying any fraction, whether it's algebraic or just a normal fraction, if you multiply it by a whole number, you're just affecting the numerator. So the denominator is still 2, because technically 6 is 6 over 1. So that's how I'm only affecting the numerator. And then, again, obviously I need to multiply the right-hand side. So again, I'll put 6 as a bracket there, x plus 4 over 3. If I now look at these two other fractions, you see how because I had 2 and 3 as factors of 6, 6 divided by 2 is just 3, isn't it? So that one just cancels out the denominator naturally, but obviously I still have to multiply everything then by 3 instead of 6. Same with this second one. 6 divided by 3 is 2. So that one just gets multiplied by 2. That's why I chose the biggest denominator. Now this only works if the other two denominators are factors of that number. In the case that you might get, it might not be, so you might have to multiply by all of the denominators individually, one at a time. You might have to do that, but in this case we didn't have to. Now I've got rid of all my algebraic fractions, I'm just going to expand and simplify and collect any of the like terms. So we've got 2x plus 1 plus 3x plus 15 equals 2x plus 8. I want to bring all the x's together, so we've got 5x plus 16 equals 2x plus 8. I'm going to move the smaller number to the left so that I have a positive amount of x's. So I'm going to take away 2x, so I get 3x. And at the same time, I'm going to subtract 16. So 8 take away 16 is minus 8. And finally, bring it over here. We obviously then divide by 3, don't we? So we get x equals minus 8 over 3. Okay, just leave it as a fraction because that's a recurring decimal and I don't really want to work it out. So I'm going to leave it as a fraction, that's absolutely fine. And there we are. So again, we just wanted to kind of cancel out those denominators by multiplying by the denominators. In this case, we were lucky because I only had to multiply by 6 in order to cancel out all 3 denominators. You might have examples where you do need to multiply multiple times by each of the denominators. In this case, it was lucky that I just chose the biggest number as they were all factors. Okay, the next one we've got now algebraic fractions where both the numerators and the denominators have x's in them. Again, when I'm solving equations, I obviously don't want to have x as a part of any fractions. So I still need to get rid of the fractions. And the way that we've been getting rid of the fractions is by multiplying by the denominators. In this case, the denominators are a bit more complicated. So the way that I think about it is cross-multiplying. I'm going to multiply by x minus 3, and I'm going to multiply by 3x minus 9. Now, some of you might have noticed, actually x plus 3 is a factor of 3x minus 9. If you notice that, again, it's very unlikely that this will happen, so I'm going to assume that we didn't have that scenario. But if you have noticed that, then just multiply by this bigger one and it will cancel out both. But I'm just going to go with the fact that we don't have that scenario, because I don't think that will happen very often. So, I'm going to start by multiplying. You can do this all in one step if you like, but I'm just going to write it out separately so you can visualize it. Multiplying by x plus 3. Obviously on the left hand side that means I just get left with 2x because it cancels out that denominator. That was the whole point. And the right hand side, again, think of x minus 3 as a whole number. That means it's only going to affect the numerator. So I will expand this later. We'll just leave it here for now. There we go. And then to get rid of the second fraction, again just do the same thing. Multiply by that denominator. And it will cancel out. So the left hand side is now 2x times by that denominator, 3x minus 9. And the right hand side obviously just stays with that numerator because we've cancelled out the denominator. So 4x plus 10, x minus 3. Okay, so I call this cross multiplying in this sense. I've multiplied both denominators across diagonally. So as I said, you might be happy to just go straight into this step here by swapping both denominators basically from the right to the left and the left to the right. It's up to you. If you want to write it out in 2 steps, as I have done, feel free to do that so we don't make any mistakes. But if you're happy to just do it all in one step and can visualize it well, that's fine. Now that I've got this, I'm going to expand everything. So I've got 6x squared minus 18x on the left. The right hand side is double brackets, so we've got 4x squared minus 12x plus 10x minus 30. If you want to go through expanding brackets, then I will link all the videos down below as well. Now, obviously in this case, I am going to be left with a quadratic. Do you see how I've got 6x squared and 4x squared? We're not going to end up cancelling them out. Because I want to solve this, and I know that it's going to be a quadratic, I need to get all the terms on one side. Ideally, I want it to be a positive x squared. So actually, I'm going to move all of this to the left. That's just my choice so that I can keep my quadratics, as in the x squared part, positive. So we've got 6x squared minus 4x squared is 2x squared. These two obviously we can add together, so we get minus 2x there, don't we? So I need to add 2x, so that's minus 16x. Then I need to add the 30. There we go, I have a quadratic and it equals 0. You can factorise it as it is, but what I like to do, I'm just going to write it up here again, is double check if I'm solving quadratics, can I simplify them at all before I start to factorise? In this case, you see how all 3 terms are divisible by 2. So I'm going to divide the whole thing by 2, just to make it easier to factorise. Literally, that's the only reason, just to make my life a bit easier. Sometimes you can simplify them, sometimes you can't. So that gives me x squared minus 8x plus 15. Obviously, 0 divided by 2 is still 0. That's a much easier thing to factorise, isn't it? So I'm going to try and factorise it. Sometimes we can't factorise quadratics, but in this case, there's been nothing written in the question that makes me assume that I can't factorise, so I'm going to go with that method. Okay, so we need double negatives. We're timesing to make 15, adding to make 8, so 5 and 3. Okay, so when I solve it, I get x is equal to 5, or also 3. There's my solutions. So sometimes algebraic fractions, when we're solving them, the previous questions we looked at were linear ones. We got just one answer, didn't we? In this case, it's actually a quadratic. We've got x squared, which means we're going to get 2 answers, so we have to factorise most likely. The key thing is, though, that when we see an algebraic fraction in an equation, we're still multiplying by those denominators, whatever they may be, in order to cancel them out. Okay, so this one, we have got something added together. The denominators are where the x's are, but we've also got this equals 1 bit. So, again, there's two ways to do this. If you would like, you can add these together. So we saw this in the previous video, where we were saying express as a single fraction. We would have to find common denominators and add them, and then we can deal with getting rid of the fraction. Or we can just get rid of these fractions straight away, as we've kind of done in that previous question. So it's completely up to you what you prefer to do. I'm just going to get rid of the fractions, because I don't think there's any point in adding them and then having to get rid of the fractions. So I need to times by each denominator. So I'm just picking the first denominator basically in this case, because there's not really much difference. Doesn't matter which one you pick first, I'm just going to go with the one that has come up initially. So multiplying by x minus 5, obviously that cancels out that denominator there, so I'm left with just 2. However, this second fraction didn't have x minus 5, so I'm not cancelling out. So if I'm timesing by x minus 5, it will actually have an effect. I do need to still multiply that by x minus 5. It goes in the numerator, and obviously 1 times x minus 5 is just x minus 5. Now, I still have one more denominator to get rid of, so I'm going to times now everything by x. Again, remember, all 3 terms need to be multiplied by x, so we've got 2x plus, now this one just opens up to be just the numerator there, because that obviously cancels out that x, equals, and then x times x minus 5. So now we've got rid of all of the fractions. Now it's just a case of expanding and rearranging, so we've got 2x plus 6x minus 30 equals x squared minus 5x. So, because we've got an x squared again, it's a quadratic, we know that we're going to need to get everything on one side and hopefully see if we can factorise. I'm going to move everything to the side where the x squared is positive, so in this case I'm going to move all of this to the right hand side. First of all, though, I can add together 2x and 6x, and then I'll move everything. So let's bring it up here. 0 on the left, we've got x squared, minus 5x, take away another 8x is minus 13x, and then we're going to need to add the 30. There we go. Now this quadratic I can't simplify any further, that's just as far as it goes, so I'm going to straight away go into factorising. X and an x, I need 2 negatives. Numbers that times to make 30 add to make 13 is obviously 3 and 10. And my solutions are x is 3 or 10. And there we go. That's it solved. So as you can see, the pattern is starting to build. Either way, we just need to cancel out the denominators by timesing by them. Just make sure that we do multiply across correctly when we have multiple fractions. Okay, this is our last question. As you can see, there's a little bit more to it. It does look similar to the previous one in the fact that it says solve 1 over x plus 4 plus 2 over x plus 11 equals 1. That's very similar. But we also have this added information where it says give your answer in the form p plus or minus root q, where p and q are integers. So this will likely be towards the end of your paper. It might be quite a few marks, it might be 4 marks or maybe even 5. But all of these things are giving me hints as to how I'm going to solve this. Obviously, I'm still going to do the same thing where I'm going to multiply by those denominators to cancel them out, but it's given me a hint as to where it's going to lead. Having a surd like this and a plus or minus is hinting to the fact that I'm going to get a quadratic, because plus or minus means 2 solutions, but that I'm going to get a quadratic that I cannot factorise like we've just done with the previous 2 questions. So that's just a heads up there. Let's just carry on as we were before. I'm going to multiply across by the first denominator. So timesing by x plus 4 first of all. Again, remember to times all 3 terms. So the first term will obviously just cancel it out, so we get left with 1. The 1 doesn't disappear, it's still there. Plus 2, we need to times that 1 by x plus 4, so that goes in the numerator. Still over x plus 11. And then 1 at the end times by x plus 4 is obviously just then x plus 4. Now, times by that other denominator, which is x plus 11. Again, remember to times all 3 terms by x plus 11. So 1 times x plus 11 is obviously x plus 11. This one, it will just cancel out the denominator, so we're left with 2 brackets x plus 4. And then the right hand side, we've got double brackets. That's where our quadratic is coming from. Now I've got rid of my fractions, I'm just going to expand everything. So x plus 11 plus 2x plus 8 equals x squared plus 11x plus 4x plus 44. Now we're going to come over here, collect all the like terms. So 3x plus 19 is x squared plus 15x plus 44. Because it's a quadratic, I do still need to get everything on one side, and I'll move it to where the x squared is positive, so I'm going to move everything to the right hand side in this case. So we get 0 equals x squared, 15x take away 3x is 12x, and 44 take away 19 is 25. Now, you could try and factorise that, because normally with quadratics we do try and factorise first, don't we? But because they've told me this, I already know that I can't factorise it. I'm not going to get a root. Like, if I can factorise, they should all be whole numbers. Where does this root come from? So I know I can't factorise. So you've got two options. I guess it depends if it's a calculator question or not. If it's a calculator question, this is hinting to me to use the quadratic formula. You can use the quadratic formula either way, to be fair. The other option is you could complete the square and then solve it that way. I feel like that might be going around the houses though, so it's completely up to you. There's different ways of doing things. As long as you get the same answer, you'll get the marks. So yeah, let's use the quadratic formula, which should be on your formula sheet, but I'll write it here anyway. Okay, so the quadratic formula works in the way that a, b and c, as long as you've written it in order, so x squared first, so a is technically 1, b is then 12, and c is 25. All of them are positive. If they were negatives, you'd have to go with that as well. So we've got x equals minus b, so minus 12, plus or minus the square root of 12 squared, minus 4 times a is just 1, so that really makes no difference, times 25, over 2 times 1, again, doesn't really make any difference. And then I would just simplify each of these parts. Again, we're not going to be working out the square root as such, just the pieces in between. So we've got minus 12, plus or minus 12 squared is 144, take away 4 times 25 is 100, over 2 times 1 is obviously 2. Okay, I've just moved everything over so we've got some more space. So that should give me minus 12 plus or minus root 44 over 2. Obviously 44 is not a square number because we're expecting to be left with a root, but that's fine. Sometimes this then includes some surds, doesn't it? So let's see, can I simplify root 44 as a surd? Are there any square numbers that go into 44? Well yeah, 4, right? So root 4, root 11 over 2. Then I can actually square root the 4, so that becomes 2 root 11 over 2. Now finally I'm just going to simplify the fraction. I've got 3 terms here. I've got minus 12, I've got 2 root 11 and 2. The root 11 part is irrelevant because that's a surd, but looking at just the whole numbers, minus 12, 2 and 2, they're all divisible by 2, so I can actually divide that. The other thing is that, do you see how my answer they've given me as the format is not a fraction? So I know that it should cancel out as a fraction as well. So I get minus 6 plus or minus root 11. And that's x. My two solutions is the fact that I've got minus 6 plus root 11 and minus 6 minus root 11. Those are the two solutions from our quadratic. But yeah, sometimes you might be left with this format. So I can actually use quadratic formula when I don't have a calculator. Obviously, if you had a calculator, type it all in at this point, and then it should simplify it for you. But make sure you leave it in the surd form. But you can still use the quadratic formula without a calculator. As I said, the other option is to use completing the square and then solve it via completing the square. That's another option. As long as you get the same answer, then it's absolutely fine. So that is everything to cover algebraic fractions. The other videos are linked down below if you want to go back and check those out. If you want to look through factorising or expanding brackets, all of those videos will also be linked down below as well. So check out any of the resources that might be helpful. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.